All right, welcome back. In this video, we're going to actually look at a composite function that's actually got two levels of composition to it. So here we have cube root of cosine of 4x. Remember, roots are fractional power, so we can rewrite this as the quantity cosine of 4x to the 1/3. And so I want you to notice here that we actually have two levels of composition. We have an inside function in the cosine, we have the cosine, and then we have the whole cube root of everything. So as we begin this, then, we're going to have to set up two levels of composition. So first off, we have the innermost function, so we'll call that u, just like before. U equals 4x. Now, because I have another level, I'm going to pick another variable. Next thing in the alphabet's v. So replace 4x with u, and we'd have cosine u. So the next level would be v equals cosine u, and replace the cosine with v, and we would have our final level, which is f equals v to the 1/3. So here we actually have three levels of composition, and so we just work through and do our derivative, just like we did before. We're going to do the derivative of f with respect to its variable, the derivative of v with respect to its variable, and the derivative of u with respect to its variable. So derivative of v to the 1/3 would be 1/3 v to the negative 2/3. Derivative of cosine u would be negative sine u, and derivative of 4x would be 4. So we have f prime equals 1/3 v to the negative 2/3 times negative sine u times 4. And we just want to clean that up some, try to simplify stuff as best we can. So I bring the 4 along with its negative sign from the sine of u into the front, and then I would have, and then I'll have sine of 4x, right, because sine of u, and then v is cosine of u, cosine of 4x. So I have cosine of 4x raised to the negative 2/3 power. Okay, so that's because it's v. V is cosine of u, cosine of 4x. Okay, and that's to the negative 2/3 power. And then just do a little bit more cleaning. Negative 4 at the top with sine of 4x over 3. Cosine, because of the negative exponent, needs to go to the bottom, so it becomes cosine 4x to the 2/3. I leave it like that. If you want to write that as cube root of cosine 4x squared, you can if you wanted to, but I usually leave these ones as fractional exponents. Okay, let's continue on to one final example here with the chain rule. Here we have x squared minus 6x plus 5 to the 3rd. So the process is the same. We have a composite function. You may want to pause the video and see if you can work this one out on your own. And so as we go through this problem now, we have u is the inside function, f then would be the outer function, which is u to the 3rd. Okay, and then we just continue working through our process. Derivative of the outer function would be 3u to the 2nd, derivative of u to the 3rd, and then derivative of x squared minus 6x plus 5 would be 2x minus 6. Then we have just one final thing that we need to deal with here, and that is that we need to put back in for u. Right? So u is equal to x squared minus 6x plus 5, so we put it all together. 3 times 2x minus 6 times x squared minus 6x plus 5 to the 2nd power. And so now we have our result here with the chain rule. In the upcoming videos, what we're going to look at is the chain rule still, but now it's going to be mixed in with a product or quotient rule, and that just really jacks up the difficulty. So it'd be a good idea to practice some with just working through the chain rule first before you start tackling those harder problems where we have a product or quotient that's also involved with the chain roll, or we could have chain roll happening a couple times. Okay, so stay tuned for those. They'll be coming up soon.